Given the scatter plot, which has 6 points as shown on the screen there, in this video I'm going to check the possible models that can be used to model the relationship between x and y. So given that scatter plot, a scatter plot just gives a general shape of the curve that we are supposed to fit. So in this case, we can look at some common curves that are there. If you look at a parabolic equation where we have y is equals to x squared, if you look at the points there where x is greater than 0, we see that it's almost of the shape which is indicated on the scatter plot there. So what we would see there is a parabolic model there will be one of the models that can describe the relationship between x and y. So we have a parabolic one we'll do there. If we check the graph of a cubic equation, y equals x cubed. Y equals x cubed, if we check again for values of x greater than or equal to 0, we see that that shape there is almost similar to the one that we have on the scatter plot there. So for the relationship that we can have there, a cubic one might be possible as well. Then if you also recall that the equation of an exponential function y is equals to exponent of x, it is of this form, and it can be shifted going up or going down. And if we shift it going up or going down, translating it, it will be almost similar to the equation which is on the scatter plot there. So in this case, again, the exponential model can also be a possible model that we can use to describe the relationship between x and y. So what you would then have to do is you try parabolic, you try cubic, you try exponential, then you check for the one which is the coefficient of determination, which is acceptable. But in this case, if you might try the equation of a straight line, a linear one, y is equals to x, we see that the points on the scatter plot there, they are not lying on a straight line. So trying a linear function there would be wasting time. So the possible ones you can try are these ones, parabolic, cubic, and exponential.